This video was based on a mathematics lesson during week 4. Overall, we had covered our planned learning intentions for the week, and I decided to run the Leapfrog activity with the students. The learning intention was to solve the Leapfrog challenge, but the ultimate goal of the lesson was to further develop students' critical thinking skills by making predictions and looking for patterns. In Leapfrog, the objective is to move one set of objects from the left to the right and another set from the right to the left. There are specific rules, as objects can't move backwards and they can only hop one space. The key is to swap the objects in as few moves as possible. I began the lesson by using students and chairs to demonstrate the activity. The students themselves would be using coloured tokens when on their own, but to introduce the topic, the students were more engaged and involved by actively suggesting moves for each other. It took a few attempts working as a class, but it was beneficial to reinforce the activity rules and strategise moves. The stronger critical thinkers supported the learning of the students who found it difficult to visualise and predict outcomes based on their decisions. I guided the process without offering answers. I used inquiry-based questioning to prompt the students to reach their own conclusions, make predictions, and learn from their mistakes. When the students were working at their tables, I roved the class and worked one-on-one with students. I also worked with small groups and encouraged active, respectful debate between peers over which move to make, as it allowed them to make more accurate choices, learn to think ahead, and recognise the pattern which needed to be achieved before the colours could be swapped. The activity encouraged students to problem solve, and all students were very productively committed to working out the least number of moves possible for 2 pairs, 3 pairs, 4 pairs and beyond. The activity was able to be differentiated to suit each individual student. Students who found it difficult to solve worked with fewer pairs of tokens, while others could extend themselves with more pairs. I also had students write their findings in their book so that we could discuss the outcomes as a class. It was interesting to rove around the class and observe the different strategies that students were adopting. Some used post-it notes to keep track of their possible spaces, whereas others drew squares in their workbooks. Some students who were normally early finishers struggled to think abstractly and took more time. During the conclusion, we reran the students on chairs example with 3 pairs and shared student results with each other. Where there was inconsistency, we used the students on chairs to problem solve and agree on the correct number of moves possible. One advantage of this activity was that students could work at their own pace and extend their critical thinking skills regardless of how many pairs they were working on. It was always challenging, but with persistence, everyone succeeded.